Good day. We'll discuss the introductory part or the part 1 for graphing rational functions. So take note that a rational function is a function of this form, where our px and qx are both polynomial or polynomials. The domain of the rational function, which was discussed in a previous video, is the set of all real numbers except the zeros of the denominator. So here are the steps in graphing rational function. Number 1 is we need first to find the domain of the rational function. But since we're done with this one in our previous video, so we'll skip this in this video. Number 2, find the vertical and horizontal asymptotes. Then next, we need to find the x and y intercepts. And then we're going to plot this on the xy plane. Then construct the table of signs. Then we need to draw the curves. Okay, but for this video, for the part 1, we'll be focusing on these numbers 2 and 3, and on the next videos, we'll be focusing on the remaining steps. So let's have these examples and terms. So vertical asymptotes. So the line x equals a is a vertical asymptote for the graph of a function f if f of x approaches infinity or f of x approaches negative infinity as x approaches a from either left or right. So say for example, we have an xy plane and we have here our vertical asymptote x equals a. So f of x, our function f of x, will approach positive infinity as x approaches either from left or right. So meaning our graph may go that way. Okay, may approach positive infinity. Take note, this is the positive infinity for our y-axis. And it will also approach the negative infinity if we go here from left or right, approaching a. Okay, approaching a. Now, the vertical asymptotes, if any, of a rational function is of the form x equals a. So the values of a are just the zeros of the denominator. So to find a, simplify first the given rational expression so that we can know that are there terms or are there expressions that can be cancelled. So that is why we need to simplify them first. And then equate the remaining expressions on the denominator to 0 and then solve for the variable. So that will be now our zeros for the denominator. So for example, we're given with this expression. So first, we need to simplify this expression to know if we can cancel something. So after factoring, so these are the factors for the numerator and these are the factors for the denominator. So after factoring, we can see that we cannot cancel anything. So we need to proceed to the next step, find the zeros of the denominator. So this is our denominator. So we already factored the denominator. And then we have 2x minus 1 equals 0 or x plus 4 equals 0. To solve for x, we have this. So x equals 1/2 or x equals negative 4. So meaning in our graph, so we have negative 4. So we have broken lines here. So this is our one of our vertical asymptotes. So x equals negative 4. And the other one is x equals 1/2. Now, why is it broken line? Because the graph should not pass through this vertical asymptote because the function will become undefined if we substitute these values to our denominator. Okay, so these values will make the function undefined. So that is why when we graph this, it will be broken lines. Okay, and the graph will not cross the given vertical asymptote. Okay, so but the point here now is to find the vertical asymptote is first, we need to simplify first the given expression to know if we can cancel something. After that, we need to find the zeros of the denominator. Then those values there will become our vertical asymptotes. Okay, take note, this is our x-axis and this is our y-axis. And by the name itself, vertical asymptote, so it should be vertical. So we'll just go back to this later. Now, let's go to horizontal asymptotes. So the line y equals c is the horizontal asymptote for the graph f of f if f of x approaches c as x approaches infinity or negative infinity. So again, this is an asymptote. So say for example, we have here y equals c. Now this is our y-axis. So the line y, the broken lines y equals c. So as x approaches positive infinity or negative infinity, f of x approaches c. So this is our c. Now it will approach c. So it may not cross c, or it may not touch c, or it may. No, it can cross c. So it can cross c. Now, unlike in the vertical asymptote, it can never cross the vertical asymptote. But for the horizontal asymptote, it can cross the horizontal asymptote, or it may not cross. So it will just approach the horizontal asymptote. Okay. To solve the intersection, to know whether the graph will intersect the horizontal asymptote, you just need to find their intersection by just solving this. Okay, the given function equals the horizontal asymptote. If you will have if you find a value here, okay, if you find a value here, x equals something, then it means that is now your point of intersection. So we have x and the value c. Okay, so meaning it means that it will cross the horizontal asymptote in this point, x equals xc point. But if you cannot find a value, say for example x here is undefined, or we cannot define, or we cannot find any value of x, therefore it will not cross the y, the horizontal asymptote. So meaning it will just be approaching the x or the y asymptote, or the horizontal asymptote. Okay, so we'll just go back to that later again. We'll have an example. Now, how do we find the horizontal asymptote? So by a theorem, so we have this as our general function for rational function, where our leading coefficients are non-zero. So note that n is the degree of the numerator and k is the degree of the denominator. So we have this: if n, or the degree of the numerator, is less than the degree of the denominator, then the x-axis or line y equals 0 is the horizontal asymptote. So automatic, the x-axis, so this is the y equals 0, this will be our horizontal asymptote. So y equals 0, so meaning our c here is 0. Number 2, if n is equal to k, if the degree of the numerator and denominator are the same, so we'll just take the division of the first of the leading coefficients. Okay, leading coefficients. And if n is greater than k, then x, or then f has no horizontal asymptote. So we'll only consider these three conditions. So as an example, or as examples, we have this: find the horizontal asymptote of the following. So this is our first example. So take note, 2 is equal to 2. So that falls on condition 2. So since they are equal, we just need to have the division of their leading coefficient. So the leading coefficient only. So that is why the answer for this is 3/2. Next, h of x. So here, if you notice, there's no x here, so meaning this is x raised to 0, right? So 0 is less than 1. So the exponent in the denominator is 1. So 0 is less than 1. So that falls on the first condition. The degree of the numerator is 0. The degree of the denominator is 1. So meaning the horizontal asymptote is the x-axis or line y equals 0. Next, g of x. So we have 1, 1. So the degrees are equal. So again, we'll have this 3/1. Take note, we have a 1 here. The coefficient of x is 1. So 3/1 is 3. So the horizontal asymptote is 3. Number 4, the degree in the numerator is 3 and the degree of the denominator is 2. So 3 is greater than 2. So that falls on condition 3. So it has no horizontal asymptote. And last, if you're given with factors, so all you need to do is to multiply the two leading coefficients. So the two leading coefficients, so this is 5x squared, and we have 3x squared. Okay, so both of them have degrees 2, 2, 2. So this falls on condition 2. So meaning we'll just need the leading coefficients of both. So 5/3. So the horizontal asymptote, therefore, of number 5 is 5/3. Okay, let's go to x-intercepts. So it is the point where the graph of a function crosses the x-axis. So this is our x-axis. So if we have a graph here, this is our x-intercept. So the point of intersection where the graph and the x-axis meet. So to get the x-intercept, simplify first the rational expression, okay, to know whether we can cancel anything. And then let y equal to 0 and then solve for x. So let's go to our previous examples. According to this, our answers are -1/3, 0, and 3, 0. So how did we get this? So we have this simplification, so we cannot cancel anything. So let f of x be equal to 0. So meaning this side must be 0. Okay, and then by cross multiplication, so this is just 0/1. So again, this is just 0. Now, if you multiply this, the result is 0 because 0 times any expression is 0. And on the right side, we are left with the numerator 3x squared minus 8x minus 3. And then factoring this one, so again, we'll just copy it here. We factored this already. And so we have two values, 3x plus 1 equals 0 or x minus 3 equals 0. Then solve for x. So we have our first x is -1/3, our second x is 3. So since it is a point, so we must pair this with our y. Take note, our y is 0. Okay, so that is why we have -1/3, 0, our first x-intercept, and another x-intercept is the 3, 0. Again, the y is 0 because we let y equals 0. So meaning on the graph, -1/3. So if this is 1, so -1/3 is somewhere here. Okay, so this is our negative 1/3 0. Okay, negative 1/3 0 and 3. So if this is 1, 2, if we have 3 here, so this is the another intercept. So this is negative 1/3 0, this one, and this is our 3, 0. So 1, 2, 3, because the x-axis is 3 and the y-axis is 0. Okay, so these are the x-intercepts. Okay, now let's go to the y-intercept. It is the point where the graph of the function crosses the y-axis. So if we have this, so this is now our y-intercept. This is our y-axis. So this is the graph crossing the y-axis. So this is now our y-intercept. So this time we will solve for let x equal 0. Okay, let x equal 0. And then we have this, our previous example. So let x equal 0. So f of 0, so we have 3, 0 square minus 8, 0 minus 3, 2, 0 square plus 7, 0 minus 4. Okay, so 0, 0. So we're left with negative 3 over negative 4. Negative divided by negative is positive. So therefore, the y-intercept is 3, 0, 3, 4. So if this is 1, so somewhere here. So the graph crosses somewhere here. 0, 3, 4. 3/4. Okay. So anyway, in the next video on the next video we'll be discussing the plotting of points and the graph of the rational function in general. So let's have this for our review. Let's answer these four rational functions. So we need to find the vertical, horizontal asymptotes, as well as the x and y intercepts. So let's start first with this. So let's simplify. We cannot simplify this one since we cannot cancel anything. Okay, because this is just equal, so 2x over x plus 1 times x minus 1. Okay, so x squared minus 1 is equal to x plus 1 times x minus 1. Okay, so take note, we cannot cancel anything, so it is already in simplified form. Thus, to find the vertical asymptote, we just need to equate the denominator to 0. So the denominator is x squared minus 1. So to solve, we have this. So x minus 1 equals 0, or x plus 1 equals 0. So we have x equals 1 or x equals negative 1. So these two are our vertical asymptotes. Okay, so I repeat, just factor the denominator or find the zeros of the denominator of the simplified form. For the horizontal asymptote, take note that the degree of the numerator is 1, the degree of the denominator is 2. So it is bigger, or the numerator is smaller than the denominator. Then the horizontal asymptote is the x-axis or the line y equals 0. So this falls on condition number 1 if you go back to the theorem. Okay, now let's go to x-intercept. So the answer now is 0, 0. So let's try. Let y be equal to 0. So this is our y. So this will become 0. Cross multiply. So we have 0 is equal to 2x. So usually in the x-intercept, we're only left with the numerator. Now if you want a shortcut, so just equate your numerator to 0. So 2x equals 0. Divide both sides by 2. X equals 0. Okay, divide both sides by 2 so that we can cancel 2. Divide by 2. 0 over 2 is 0. So pair them, y equals 0 and x equals 0. The x-intercept therefore is 0, 0. Now for the y-intercept, let x equal 0. Then we have h0, 2 times 0 divided by 0 squared minus 1. So again, you just substitute the zeros from the given rational function. So of here, 0 over negative 1 is 0. So therefore, our y-intercept is 0, 0. So we have our x is 0, our y is also 0. Okay, now let's go to B. So again, this is in simplified form. We cannot cancel anything. If you notice, we cannot cancel anything. Do not cancel 3 because of this symbol minus. We cannot cancel 3. So for the vertical asymptote, x minus 3 equals 0. So transposing 3 to the other side, we have x is equal to 3. Horizontal asymptote, the degrees are equal, 1, 1. So since they are equal, we'll just need to get the ratio of the leading coefficient. So the leading coefficient of this one is 3, of the numerator is 3. The leading coefficient of the denominator is 1. So 3 over 1 is 3. So the horizontal asymptote is 3. Okay, let's go to the x-intercept. So let y equal 0. So this one will be 0. Okay, and cross multiply. So again, the numerator will be left. Okay, if you cross multiply, 0 over 1. So 0 equals 3x. Divide both sides by 3. Diba? We can cancel 3. 0 over 3 is 0. So x therefore is 0. So again, the same with example 1. Our x-intercept is 0, 0. So y-intercept, let x equal 0. Then, okay, we have here, substitute the x equals 0. So we have 0 over negative 3. So this is negative 3. So 0 over negative 3 is 0. So our y-intercept is, again, 0, 0. So take note in writing the ordered pair, it should be x, y. So our x is 0, our y is 0. Okay, next, let's go to C. So we have this expression. So simplify. Okay, here we can cancel x minus 1. So we will not include x minus 1 for our vertical asymptote. So we will focus only on this final expression or the simplified form. Okay, so the denominator is x minus 4. So to solve for the vertical asymptote, we equate this 1 to 0. So transposing negative 4 to the other side, we have 4x equals 4. Okay, for the horizontal asymptote, the degrees are equal. So degree, so 1 over, not 1 over 1. So the numerator is 1, the denominator is 1. So they are equal. So according to the theorem, we'll just need the ratio of the leading coefficient. So 1 and 1. So 1 over 1 is 1. So let's go to the x-intercept. So to the x-intercept, so let y equal 0. So this will become 0. So here, x minus 3 equals 0. Okay, so if we cross multiply again, or if you want the shortcut, numerator equals 0. So transpose 3, we have x is equal to 3. So our x value is 3, our y value is 0 because we have let y equals 0. And for the y-intercept, so let x equal 0. 0 minus 3, 0 minus 4, so 3 over 4. So we have now, our x is 0, so that is why I wrote here 0 first. And then our y is 3 over 4. So that is why on the next uh, ordinate we have 3 over 4. And last example, so we're given with this expression. So if you notice, we cannot cancel anything. So we'll proceed with the vertical asymptote. First, equate the denominators to 0. So we have 3x minus 4 equals 0, or x plus 2 equals 0. So transposing negative 4, it will become positive 4. And then dividing both sides by 3, we can cancel 3. So we have x is equal to 4 over 3. And the second one, transpose positive 2 on the other side, it will become negative 2. So the second vertical asymptote is x equals negative 2. Now, horizontal asymptote. So note that if we do the FOIL method, so if we do the multiplication, we have this. Okay, but of course, for the shortcut, you can just multiply the two leading coefficient, the leading coefficient only. You can do that for the horizontal asymptote. So 2 equals 2, the degree of the leading coefficients, or the degree of the numerator and denominator are equal, then we'll follow the condition number 2 of the theorem, meaning we'll just take the ratio of the leading coefficient of the numerator and the leading coefficient of the denominator. So we have y is equal to 5 over 3. And for the x-intercept, so let y equal 0. So this will become 0. Okay, and then cross multiply. So this is 0 over 1. Okay, so we have this. So therefore 5x minus 2 equals 0, or x minus 2 equals 0. So solving for x, we have x is equal to 2/5 or 2 over 5, and x is equal to 2. So there are two values here actually. The first one is 2/5, 0, and the other one is 2, 0. So we have two x-intercepts for this problem. The 2/5, 0, and the 2, 0, since we have two values of x. And last, for the y-intercept, let x equal 0. Then we have here, so substitute 0. So this will become 0, this will become 0. We have 0 minus 2, and we have 0 minus 4. 0 minus 2 is negative 2, so that is why we have negative 2. 0 plus 2 is 2. Okay, take note that this will become negative 2. So negative 2 times negative 2 is positive 4. Negative 4 times positive 2 is negative 8. So we have 4 over negative 8. So lowest term, this is equal to negative 1/2. So therefore, our y-intercept is x is 0, and our y is negative 1/2. Okay, so on the next video, we will be graphing these examples.